This is April 2nd. We are looking at the second part of section 8.1, covering examples 5 and 6. Remember when we left off, we said that the index can be any number, any letter, starting, doesn't have to start at 1, it could start at 0, or whatever number you want. If you look at example 5, so this is in your textbook on page 413, looking at example 5, finding the sum of a series. In this case, the series is defined to be 3 plus k squared, and we were starting at 4 and going to 8. And so if we rounded out ourselves, we would do 3 plus 4 squared, 3 plus 5 squared, 3 plus 6 squared, etc. So 19 plus 28 plus 39 plus 52 plus 67 equals 205. That is tedious. You can do these on your calculator. Get your calculator out so you can follow with me. Do this on your calculator. Take a minute, go get it. Once you're there, choose second stat, over to math, and pick 5 for sum. Now your calculator screen would show sum and a parentheses. At that point, you're going to do second stat again. This time, take your arrow cursor and go over to ops and pick 5 for sequence. At that point, you're going to see a screen that says expression. That's what you're putting, that's the expression that you're summing. So in this example, you would do 3 plus x squared. The variable is going to be x. You're going to start at 4. You're going to end at 8. And you want the step to be 1. When you've entered that, press enter. When it says paste, press enter. And now your screen should show sum, sequence, 3 plus x squared. That's what you're summing. The variable is x. You're starting at 4. You're going to 8 in a step of 1. Press enter. And out will come 205. So I can do this manually. I can do this with my calculator. If you do it with your calculator for a quiz, just show me the setup and then end with the work. So again, that was second stat, math, pick 5 for sum. Once that's showing on your screen, pick second stat, take your arrow key over to ops, and down to 5 for sequence. On that screen, you're going to enter the expression that you're summing, where you're going to start, where you're going to end, and you want to go by ones. When you press enter, on your calculator screen, you should see sum, sequence, the expression that you're looking for, the variable that you're using, starting, ending, and the step that you're using. At that point, press enter, and out should come the answer. You can tell this is tedious, and so there are some formulas for special series that we would want to memorize. So if I'm summing sum from I equals 1 to n of the number 1, it's just n. So if I want to add n 100 times, the answer is just going to be 100. Might be common sense, but there's a little formula to remind you. If I want to sum the first positive integers, I would look like that, but it would, the answer, without having to do it with my calculator, is just n times n plus 1 over 2. This was the classic problem. There was a student named Gauss, who's famous for lots of other things too. He made tape that you could hold data, but when he was young, he annoyed his tutor greatly. And his tutor asked him to add the integers from 1 to 100, and he thought that would keep him busy for a while. Well, Gauss came back in seconds with the answer, and the tutor was floored. But the way that he did it led to this. So if you think of those numbers, 1, 2, 3, 4, 97, 98, 99, 100. What Gauss noticed was that if he paired these, he would have 101, and 2 and 99 was another 101, and 3 and 98 was another 101. So if he did that, n plus 1 times n, and divided by 2, out came his correct answer. So we have him to thank for this. This is a little bit more laborious to derive, but if I am summing the squares of the first positive integers, the summation would look like that, but the answer would look like n times n plus 1 times 2n plus 1, all over 6, all divided by 6. This is in that core concept box, and look at example number 6, using a formula. So this is on page 413 in your textbook. Using a formula for finding a sum. So if I'm looking at looking at example 6, they send us back to that apple problem where you had layers of apples and n squared was the summation. And so they want to know how many apples are in the stack in example 3. So remember the nth term, a sub n, was given by n squared. And n was 1, 2, 3, up to 7. So we had 7 layers, and we want to know how many times is that? Well, it was n squared. So that third formula that I should erase was n equals 1, 2, in this case 7, and it was n squared. And so we're going to remember that that formula was n times n plus 1 times 2n plus 1, all divided by 6. So if I'm plugging in, I have 7 times 7 plus 1 times 2 times 7 plus 1, all divided by 6. So I have 7 times 8 times 15 divided by 6. I can make it a little smaller for myself by reducing, but either way, I'm going to, you can see that, either way I'm going to get 140. So I'm looking for those apples were n squared. I'm looking at that third formula. It said if I'm finding the squares of the first, in this case 7 integers, I can use this formula. So in this case, my n is going to be 7. 7 times 7 plus 1 times 14 plus 1, which is where this came from, dividing by 6, because that's what that formula said, and I'm out with 140 for my answer. If you look at monitoring progress, down at the bottom of page 413, see what we can do. Number 13, these are to do by hand, but you can check with your calculator. This was the summation from I equals 1 to 5 of 8 times I, which is 8 plus 8 times 2 plus 8 times 3 plus 8 times 4 plus 8 times 5, which equals 120 when you do the math. If I'm looking at 14, and it was the summation from k equals 3 to 7 of k squared minus 1. Again, we plug in, which I'm going to leave for you to do, and the answer should have been 130. For number 15, it was asking you to sum from I equals 1 to 34 of 1, and we know from that formula, that's just going to be 34. If I'm looking at 16, it was the summation for k equals 1 to 6 of k. Well, that's Gauss's favorite one, so that's going to be 6 times 6 plus 1, n times n plus 1, divided by 2. So 42 divided by 2, or 21. A whole lot easier even than using your calculator to calculate. And number 17 was a chance to use the I squared one, where the summation was, you can see better if I'm on this side, was I equals 1 to 9 of I squared. And we remember that that formula was n, so 9 times n plus 1, so 9 plus 1, times 2n, so 18, plus 1 all over 6, and so 9 times 10 times 19 divided by 6, or 285. Homework, this is a short video, this is a short night, I hope. Homework is to do the practice worksheets on section 1, worksheet 1 and worksheet 2, and I will see you tomorrow.